Hello all, welcome to the channel. In this video, we will talk about Zener Diode. What is Zener Diode? A Zener Diode is a semiconductor device that plays a crucial role in electronic circuit. Basically, this is a semiconductor device which plays a very main important role in electronic circuit, particularly in voltage regulation application. So this is the symbol of Zener Diode. So in this, like this shape, Zener diodes are normally found in orange color, and you can see a black strip on the cathode of this diode, and on the anode side there is nothing, so you can identify that which side is anode and which side is cathode. At its core, a Zener diode is designed to operate in reverse bias mode. It does not work in forward bias mode. So in reverse bias mode, its anode is connected to negative terminal and cathode is connected to positive terminal. You can connect this like this. So anode is connected to negative and cathode is connected to the positive of power supply. One of the key characteristics of Zener diodes is their ability to maintain a constant voltage. One of the key characteristics of Zener diodes, their ability to maintain a constant voltage across their terminals, which is known as Zener voltage. This voltage remains relatively stable. So this voltage normally remains stable over a wide range of current flowing through the diode. This unique property makes Zener diodes ideal for voltage regulation in various electronic circuits, ensuring a consistent output voltage even in the presence of fluctuation. If there is some fluctuation in input side and there is some variation in load side, so normally its voltage will remain constant across this diode. So now we will see the circuit, how can you make the circuit and how it is connected in a circuit. So what precaution you need to take. So this is the circuit. So this is our power supply, which I have taken 24 volt DC, and this is one resistor. This is our current limiting resistor. Normally we use current limiting resistance in series of diode. So Zener diode is also a diode. So we are using here 100 ohm current limiting resistor. And our load, I am assuming that our load resistance is 500 ohm. So I have taken a Zener diode of 15 volt. So as I told you earlier, the voltage across the diode remains constant. So this diode is of 15 volt. So voltage across this diode will remain 15 volt. And this load, you can see this load is connected in parallel of this Zener diode. So same voltage will remain here, 15 volt. So out of 24 volt, here we have 24 volt and here we have 15 volt. So remaining voltage will be across this resistor. So this resistor, there will be 9 volt. So 24 minus 15 is equal to 9 volt. So we have voltages and resistance here and here. So now we can calculate the current which will be flowing through this resistor. So with the help of Ohm's law, we can easily find out the current. So current will be here 30 milliampere flowing through this resistor, and what current will this resistor will be 90 milliamps. Ohm's law says that 90 milliamps current will be flowing through this resistor. So total current is 90 milliamps and 30 milliamps current will be flowing through our load. So remaining current will be flowing through this Zener diode. So what will be that amount? That will be 60 milliamps current. So this is the circuit. Normally this circuit is used. So what are the precautions? The first main precaution is that Zener diode must be connected in reverse bias. If suppose if you connect this in forward bias, what will happen? It will conduct on 0.7 volt only. 0.7 volt and heavy current will be flowing through this and it will get damaged. And another is you should use a current limiting resistor. So this is very short video about the Zener diode. So that's all in this video.